But we're going to get started straight away talking about food, cities, and where AI will be in 5 years. Please welcome Tony Xu, CEO of DoorDash, and he will be interviewed by our own editor-in-chief from VentureBeat, Blaise Zarega. Please give him a warm welcome.
Hello again, everybody. And it's a good timing to be talking about food just after lunch, I suppose.
First session after lunch.
Yep. And our topic it should be AI, cities, and food. I think it's similar. It's food, cities, and AI. Okay, so DoorDash. Company's been on a tear. It's a 4-year-old company. In March, they raised $127 million in investment. In May, they reported a 25% increase, which VentureBeat covered, 25% increase in orders using personalization, using AI. And in June, they began delivering alcohol with meals in Southern California. Right? So let's drink to that. We'll do that later. Okay. And machine learning, in speaking with Tony before this, discovered that machine learning has been part of your company's DNA from the very beginning, from the time of the 2-bedroom apartment in Palo Alto or Stanford dorm room, wherever your origin was. So tell me, how did you decide from the get-go to look to AI to help your business?
Yeah, well, I don't think we looked at AI necessarily as the reason for starting DoorDash. I mean, DoorDash's mission is to build the last mile for commerce, and one of the things that's very difficult about the problems we solve on a daily basis is that there's lots of information. Information in the software world as well as information in the physical world, and from day one, our thinking on this was that in order to actually create a business that can bridge the online and offline worlds, we needed to build a company that was very good at 3 things. We needed to be very good at collecting information. We needed to be very good at building strong operations, and we needed to build world-class technology. And so from day one, it was this understanding of DoorDash at the end of the day has to be a phenomenal measurement and data business, right. and it started there from that understanding. And as we started building our data sets and improving our own operations, that's when we can employ some of the techniques that you talked about.
So let's slow down and look at then gathering data. When it comes to food and your business, there's restaurants, there's consumers, and there's also dashers. You've got 100,000 dashers now. So what data are you collecting from each of those different streams of information? And how do you marry them all?
Of course. Well, we're collecting all the inputs necessary to fulfill one delivery correctly, and just performing lots of those over that same unit time, right? So for example, we're collecting information about from consumers, what preferences they may typically order in. We'll collect information from merchants around how long it takes them to prepare certain meals, or which parking spaces seem to be easier to take versus others. And with dashers, we're constantly making sure that there is a great match between the dashers and the orders. And so what is the performance of certain vehicles, and what are the best routes for those vehicles to take?
Yeah, and let's go a little bit more detail on some of those examples of those complexities. So thinking of an urban environment like New York, bicycles are a very common form of delivery. San Francisco, not so much. I'm guessing with the hills, maybe so. But so in looking at the ease of use for a dasher, and do you actually, how do you measure that? How do you track that? Availability of parking is something you cited.
Well, I mean, as with all good data sets, you start by collecting what you're able to observe.
Okay.
And you're constantly making sure that you have a high quantity and high fidelity data set, right? And so, for example, let's take the example you listed, right? A Dasher in San Francisco versus a Dasher in New York City, both on bicycles, right? The first thing we have to understand is, well, what's the carrying capacity of this vehicle, right? Secondly, what is the Dasher's ability to actually traverse the same distance? Like you said, there's altitude differences here in San Francisco. There's parking differences. There's also differences at the consumer. There are a lot of high-rise. There are more high-rise buildings, for example, in New York City than there are here in San Francisco. There are more buildings in New York City that require a security check than, say, buildings here in San Francisco. There are smaller restaurants in New York City, actually, than restaurants even here in San Francisco. And so all of these things, we start by making an estimate and then using all of our products for our Dashers, merchants, and consumers to collect, to keep improving as we fulfill every order.
So then, okay, so I think I get a broad understanding of how you're harvesting all this information. But what about then the one-off? So a chef is sick that day, or the restaurant is out of, I'm ordering dinner for my nephew, my little Jimmy or something, and he really wants a hot dog from someplace, and they're out of hot dogs. How do you get that information into your system, or how do you deal with that data because it's such a one-off?
Yeah, so our philosophy is always, you first and foremost want to be pragmatic, right? Technology that does not solve problems are less useful than technology that solves problems. And so the first thing we optimize for is not necessarily the edge case, but the 80%. But in terms of the edge cases that you're describing, the most important thing for us, or the principle that we live by, is we expect things to go wrong. And as a result, we are building products to both minimize the errors before they happen, as well as correct those errors in real time. And so in order to do that, you have to build lots of great machine learning predictors, but you also have to build extraordinarily strong infrastructure so that you can run a lot of very computationally intense and expensive calculations in a very short order.
And so then I'm assuming you were talking millions of transactions per second?
Millions of computations per second.
Okay, and you're dialing up AWS instances, and how do you, I guess my question is, in doing so, I try to get an answer from a couple other people, yesterday and today about, is there a magic time frame when you need to, the consumer's on the app, they want to order, they're hungry, little Jimmy wants his hot dog, whatever. How quickly do you have to get that recommendation to somebody? Is there a magic 3 seconds, 10 seconds?
Well, those recommendations.
Or personalization, or
personalizing the app.
Yeah, I realize I'm conflating here.
Yeah. Well, there's two things we're talking about. One is making sure the ordering experience is tailored and custom, and the second is making sure the delivery shows up accurately and on time, right? And so on the first, a lot of that work is actually done, a priori, in which we can send information to you by email, we can send information to you through the app, we can send information, obviously, as you are searching, that is, custom and tailored for each customer, in which it makes the most relevant experience for you. And then on the second type of topic of fulfilling orders accurately and on time, the execution of those actual orders, there's a lot of products we have to build to make that successful.
Sure, right. And let's go back then to the recommendation.
Sure.
Tell us about that 25% uplift that you saw. You talked about in May with us.
Yeah, so the 25% uplift was in-app conversion.
Okay.
And one of the things that we've come to learn is that there are a lot of restaurants in America. There are over 750,000 that offer takeaway. There are millions more preferences from consumers that go on top of that. And when you add in the fact, when you multiply, that preference graph or taste graph by the number of times customers will actually edit their orders, you get tens of millions of differences of orders, right? Some people want to add avocado, other people want to remove the bacon, so on and so forth. All of these edits multiplied by the number of tastes, multiplied by the number of restaurants, multiplied by the number of times you can change a menu, That's what makes the problem very, very difficult and much better suited for the world of machine learning and less suited for human computation.
Right. And so we began our conversation. You mentioned that from the very beginning, DoorDash was built with the last mile in mind. And, you know, it's no secret, I guess, but, you know, everything you're built for restaurants could be applied to local businesses, to hardware stores. I could get a hammer that way. And really talking about, though, is not just the future of commerce, but the future of cities as well. And so what do you see, you know, using perhaps restaurants as a leaping off point, or what do you see changing in cities, and how does DoorDash fit into that vision in 10 years, 20 years, where we are?
Well, if you think about, you know, the rise of DoorDash in the last 4 years, a lot of that was occurred because of growing expectations from consumers for convenience. You know, 50 years ago, one person may stay at home while the other would go to work. Today, everybody goes to work, and today everybody works more than they did before. And in that world where convenience is king and queen, stores need to be able to change to respond to that. I think that, you know, stores either are going to become a showroom and offer you an amazing experience that you want to have. Maybe it's that Michelin star restaurant or that you know, beautiful looking retail store, or stores are going to offer you convenience and that has to happen through something like delivery. And really this bifurcation of stores is going to occur faster and faster over the next few years.
So then would we see meals being delivered by drones or robots? And how would the cities change to support that?
I think it's a sequencing game. You know, there will be a world of showrooms and convenience. DoorDash's goal is to dominate convenience, but the path in getting there is going to take multiple forms. We're not going to be able to just jump to an end state where there are only warehouses inside cities or kitchens inside cities and drones flying everywhere. That's not exactly going to be the end state tomorrow. Again, it requires both software and infrastructure, physical infrastructure, to be built. And so, you know, DoorDash today is a data technology logistics business. In order to evolve into a world that can change physical infrastructure, DoorDash has to get into real estate. DoorDash has to get into city planning and work with a lot more stakeholders to make that world come true.
Okay, so let's stay on this. So there seems to be an opportunity then, and something that we yesterday talked about this with Walmart a little bit, how basically they said they'd be willing to work with someone like Uber. They already have their own logistics, and we were talking about associate delivery, but you've got this, 100,000 strong army of dashers, people carrying things, but you're also suggesting that the future of delivery could be robots or drones. And so how do you mentioned getting to urban planning, working with local governments. I mean, is that something that you anticipate doing in the next few years?
It's something that we absolutely have in our plans. If you think about how this has to work, this is a complicated system that we're building. Just software alone, DoorDash has over a dozen products. But to make happen just one successful restaurant delivery, that's what it takes. Now to do all of the things that you said, to service different types of stores, to service different types of operations, there's a lot of other things that we have to go and figure out.
But it seems like
it's a must-have. It's a prereq in order to build this type of company that bridges the online and the offline world. It's not enough to just build software.
Yeah, obviously I'm in no position to tell you how to run your company, but it seems that if you've solved food, which is, think of have it your way to the nth degree, all these different permutations of, restaurants and dashers and consumers and traffic conditions and high-rise buildings, that delivering a hammer from the hardware store would be very easy, and that it's low-hanging fruit for you.
I wouldn't say it's low-hanging fruit, but food certainly is the hardest.
Yeah.
And if we can get food right, we can get anything delivered.
Right. Wow. And so could we see? I mean, we tried to hit you up on this earlier, but I mean, the idea of tunnels through the cities, robots carrying meals that way, or using, sort of, in San Francisco, we've got a lot more bike lanes than we used to have. Sidewalks have gotten wider, fewer cars on the street. That's been decades in the making. Could we see something more rapidly happen when it comes to this type of infrastructure, city of the future, changing retail space, so on?
I think these changes will definitely happen faster than previous decades, but I still do think they will be measured in years, not necessarily months. Okay. Again, yeah. we're talking about changing physical infrastructure in places that have a large impact on a lot of people, not just consumers per se, but the workers in the city, the staff members in the city, the governments.
So really, you're saying that in some ways, the future of tomorrow, the city of tomorrow will be optimized for this sort of AI commerce, this convenience, this loyal.
Well, I think
that becomes one of the drivers then.
The city of tomorrow is going to be optimized for more and more convenience, and technologies like AI, you will see in many facets of it, because again, in the world of bits and atoms, especially lots of bits and atoms, we have to use computing, AI being one of the technologies, machine learning, and many, many other things in order to make this happen.
Wow. All right, well, Tony, you fill my stomach, and now you've blown my mind. So thank you very much.
Thanks.
Thank you, everybody.